Thanks, Cameron. So I'd like to take the time to show you some of the examples that we have running on the ZUBoard and the DualCam SYZYGY. So the setup I'll be using is a Windows-based PC along with the ZUBoard. So we have this connected up to a USB-C supply. We have the ZUBoard connected up to the PC with a USB UART for terminal access, as well as a Ethernet cable. And I also have a USB camera connected to the USB port, as well as the DualCam SYZYGY, which provides two MIPI cameras to the system. And I have this hardware set up on my laptop, as shown in this image. So to get started, press the power button. This will boot our embedded Linux. At the boot prompt, I will just configure our static IP address. If we start looking at what's on our system with the XMUtil utility, we can see that we have several apps running on this. The two that we'll be covering are the benchmark and the DualCam DPU designs. And we can see here that the benchmark app has been loaded by default. Now this design contains the DPU engine, which allows us to accelerate deep learning models in the programmable logic. And we can actually query the characteristics of this DPU, and we can see it's the B512 architecture. So that's the largest DPU that fits inside this ZU1 device. Actually, I will switch over to Mobile Extern so that I could stream video to the PC using X1 forwarding over SSH. Alright, so if we do the same querying, we can see we have our apps and the benchmark is loaded by default. If we go to the Vitis AI demos directory under the Vitis AI library samples, we can see that there are many examples, including image classification, object detection, as well as image segmentation. And these are making use of the pre-built models that are available in this Vitis AI library models directory. So quite a few. You can see there's hundreds of models that are available out of the box and have been pre-compiled for the B512 running on the ZUBoard. So if we go run a few examples, let's say face detect, and we can see we have our face detection running in real time. And if we run a different model, let's take pose detect, once again with the live USB camera. We can see that I'm a little closer for this, but we can see we have the pose detection going on, once again in real time. And these examples all are included with source, so they can be modified to your needs. An example of this is I took the face detection and added some Centroid-based tracking to it. So this is an amusing demo where you can see that I have tracking the idea of the face and also doing a little line of the movement that was going on. Another example is head pose. So in this case, we're taking face detection, adding face landmarks, and based on those landmarks comparing to a 3D model of the head, we're estimating the direction of the gaze. So another example. And we also have some Python-based examples that are available on here. And I'll just show one that's based on a web server, so Flask-based web server. So you can see here we have the same examples we had before, so face detection, we could add landmarks, we could do our head pose. and even do our tracking. This one doesn't have that red trailing line, but you can see that this provides a good framework to explore your own ideas on the ZUBoard very quickly. Turn that web server off, and if we go back to our applications, now we will switch to a different design. We'll switch to DualCam DPU design, which, in addition to having a DPU engine, also has the MIPI capture pipeline, which will allow us to access our MIPI cameras. So the first thing to do is to unload the existing app. So if we do our list apps again, we can see that none of the apps are currently loaded. If we load our DualCam DPU, and we can see here that our DualCam design is loaded by using the media control. And we can even query which on semi image sensors. So we can see we have two AR0144 image sensors that are accessible through the V4L2 Linux API. So now if I launch my stereo face detection example, so we can see here we have face detection being done on both the left and right sides of the image. So the images we're seeing, left is left, right is right. On the right side, we have a white and cyan region of interest, which corresponds to the left and right bounding boxes. And you'll notice that they're not at the same place. And this is what we call disparity. So there's a disparity between the left and right images. And by knowing the baseline and the focal length of our two image sensors, we're able to triangulate the distance, which is being displayed on the left side. So we're displaying the disparity in pixels as well as the distance. So I'm about half a meter away from the ZUBoard, which is, and we're reporting this as the measurement. And the bounding box on the left is green when I'm in the half a meter to 1 meter range. So if I get too close, it'll turn red. And if I go too far, it'll also turn red. So this just identifies that we have a face at a distance that we were comfortable doing something else. So you could add your additional processing on this. So this could be like an access point if you want. And that's the quick overview of the demos that are available today on the ZUBoard. I hope you like this. Thank you very much.